So at first glance, this last one seems like it's primed for the root test because because it's a something to a kth power. So rho would be equal to the limit as k goes to infinity, because this one's a k one, of the kth root of 1 plus 3 over k to the k. Technically absolute value. So I can just put absolute value symbols right here and that'll work. Okay, but that's the limit as k goes to infinity of absolute value 1 plus 3 over k to the k all to the 1 over k. And the k and 1 over k part will go away. So that'll leave us the limit as k goes to infinity of the absolute value of 1 plus 3 over k. But that's 1 plus 3 over infinity, which is 0 for this part, so that would be 1. And that's a problem because that means that the root test is inconclusive. So even though it seemed perfect for the root test is inconclusive. So we're going to have to go back to the map and figure out a different one, which actually kind of leads into the next section, although we're not there yet. But we'll have a big list of all sorts of root tests, all sorts of tests, and the root test is just one of them. So the root test failed, so we would have to try something different, right, of all the tests that we've learned, like the divergence test or the integral test or the ratio test or something like that. So that's what we would have to do. Unfortunately. All right, so let's think about it. What's something we could use? So just kind of looking at it and thinking about the limit as we head towards infinity, so where this is going. It seems to me that as I head towards infinity, kind of by the same argument I just made here, this isn't going to go to 0, right? It's probably going to go to 1, right? It just seems like that might be the case. I don't know, but I'll have to prove it. But it seems like it might fail the divergence test. And if it fails the divergence test, then it's divergent and we're done. This is not the only way you could do this. You could try the ratio test and see if that gets you anywhere. Maybe it will, maybe it won't. You could try the integral test. I mean, you could try comparison. The thing with comparison is I don't know anything I can compare this to directly, not easily. So I'm kind of avoid at least the direct comparison test. So it seems like it's going to fail the divergence test. So I think we're going to try that instead. I'll just write that up. And I just wrote that up real quickly. It seems like it might fail the divergence test. Remember the divergence test, and it's on 2 pages from now. Divergence test, if the limit of your sequence values is not 0, right? So it seems like that might be the way to go. So let's try it. Okay, so we want to find the limit as k goes to infinity of 1 plus 3 over k to the k. All right, well, that's going to be kind of brutal. And we want to show that it's not 0, essentially. But we have this kth power in there, which makes things icky. So what I'm going to do is I'm going to call that L. That's the limit I'm looking for. But instead, what I'm going to find is the natural log of L. And this should be looking very familiar because we've done this before. So that would be the limit as k goes to infinity of the natural log of 1 plus 3 over k to the k. We did this before. We did this in the L'Hopital rule section, amongst others. So this is the limit as k goes to infinity of k times the natural log of 1 plus 3 over k, which, well, I'm not to infinity over infinity yet. I'm getting there, right? So it's 1 to the infinity power. So if you see the way we have this, if you're taking this, this one was 2. This was 1 plus 3 over infinity. So that's 1 to the infinity power. That's why I'm using this little trick. We learned this in the L'Hopital rule section. So this is still the natural log of 1 to the infinity, so that's not really helping. And then this is infinity times, well, natural log of 1, so it's infinity times 0. So it's not quite there yet. We're getting there, right? So now I need to turn it into either 0 over 0 over infinity. So remember the trick for that is to write the limit as k goes to infinity. I'm going to write natural log of 1 plus, I'm just going to rewrite this, 3k to the negative 1, because I know I'm going to have to take a derivative in a minute. And then we take this k and we make it 1 over k, right? Because k multiplied is the same thing as 1 over k in the denominator. And now we're cooking with gas, because the natural log of 1 is 0, and 1 over infinity is 0. And now I can finally have it in an indeterminate form that I can use L'Hopital's rule on. So I'm going to use L'Hopital's rule. And that would mean the limit as k goes to infinity of, okay, the natural log of this, the derivative of that is 1 over 1 plus 3 over k, right? Or 3k to the negative 1, whichever way you want to write it, times the derivative of the inside part. But the derivative of the inside part is negative 3k to the negative 2, right? Chain rule. So the derivative of natural log is 1 over, so you take all this stuff and put it in the denominator, and then the derivative of 3k to the negative 1 is negative 3k to the negative 2. And this, of course, is k to the negative 1, so the derivative of that is negative k to the negative 2. These will divide away, right? And so will the negatives here as well, right? So it'll just leave us 3. So that means that I'm taking the limit as k goes to infinity of 3 over 1 plus 3 over k, right? Because the 3 is left, that's that 3 right there. 1 plus 3 over k is right there, and the negatives went away, and the k to the negative 2's went away. But 3 over infinity is 0. So this would be 3 over 1 plus 3 over infinity, which is 3 over 1, which is 3. You know what 3 is? 3 is not 0. Well, we're not there yet. We're not there yet. I'll just leave it like that. Because remember, this wasn't really L. This was the natural log of L, right? So that means that L, the thing I was looking for, is e to the 3. And e to the 3 is not 0. So it's not that 3 is not 0. It's that e to the 3 is not 0. And therefore, my series, which was 1 plus 3 over k to the k, diverges by the divergence test. Because the limit, as we went to infinity, was e cubed. But we had to do a lot of L'Hopital's rule to get there. Well, actually a lot of algebra manipulation to be able to use L'Hopital's rule, and then a little bit more algebra manipulation.